All right, so let's go ahead and start putting things together here. So hopefully we can really have a solid grasp on interfaces and abstract. Now, we talked about interfaces separately with abstract classes. Now, in Dart, fortunately, or unfortunately, it depends on how we put it, the interface keyword is actually not used anymore. They got rid of it and in favor of abstract, because those two, interface and abstract, they kind of have the same sort of meaning, really, when we are putting together our classes and trying to conceptualize the idea of abstraction and interfaces. Okay, so in the documentation, they say that every class has an implicit interface, right? So which means it's not explicitly, like in the background, all classes have some sort of interface capabilities. Hence, they rely more on using the abstract classes. So let's look at our example here. I called it interfaces, right? So what I'm going to do here, I'm going to try to mimic this whole, at least most of this diagram here, so we can really understand how to implement abstract and interfaces implicitly, if you will, in Dart. What I'm going to do at the top here, let's go ahead and create a, say, class animal. Okay, and we said that animal should be an abstract because, well, it's just an idea. So I'm going to go and say abstract class, like this. So abstract class animal, that's how you do it. Abstract classes often have abstract methods. Okay, what is an abstract method? Well, an abstract method is, again, this idea of a method, which means it doesn't have any implementation. So for instance, I would go say void. I'm going to say, for instance, breathe and put semicolon like this. Why is it that the abstract method doesn't have a body? Well, because the idea here is that this is going to be just a mold, a non-concrete, an idea, a concept of what an animal is, which means we need to actually have concrete classes, would be person or felines or cats, that will inherit or extend the animal class. And then only at that level, at the class level, at the children class level, that we'll be able to then inherit or implement the breathe, because we need to implement different ways of breathing. Let's say canines have different ways of breathing than animals such as hippos or people. And okay, so we're creating this mold which we can always use to create concrete things, in this case concrete animals, which are the actual concrete animals types. Okay, so this would be an abstract method. Also, we can create methods that are not abstract, which means that have some sort of a body. We can say make noise, and I can go and say print making animal noises. Just like that. Okay, you may say, okay, well, we have that class. We can go ahead and say var animal is equal to new animal. Let's see what's going to happen. However, abstract classes can be created with a new expression. Okay, so now we have a problem. You may say, okay, Father, this makes no sense. So we are creating an abstract class called animal. We can't instantiate it. Well, the whole idea of creating a class is so that we are able to instantiate it and create objects. That is the whole idea. So why in the world would this be appealing to anyone? Why? That's a very legitimate concern and question. Remember, again, the idea here is that this abstract class is a mold of what will be. It's not supposed to be a concrete, because if we say new animal, we are asking to actually create an object. We're not creating an object off of the abstract class. That is not the idea here. The idea is for us to create a concrete classes which will then inherit from our animal abstract class and implement the methods themselves. Okay? And you will say, okay, why is that so important? Well, it's important because this is the foundation of one of the foundations of object-oriented programming language, because now we are given a lot of flexibility on what we can do when we create our classes. And it may not seem very important at this point, but believe me, this is very important when you start creating software that is really scalable and efficient and robust, because we get all this flexibility. Okay, so now what we can do, I can create another class. Let's go ahead and create, I'm going to call this a person. Say person. Okay, you can say string, just very name and nationality. Okay, nothing big here. I can go ahead and say implements animal. Look at this. Look at the contract. Because it says missing concrete implementation of animal that breathe and animal make noise. Click in here. Look at this. Create missing overrides. Aha! This is where the fun begins. Now we're saying, because we're implementing animal in the contract, when we implement an abstract class, in the background is also an interface, we must implement whatever methods that we have inside here. Why? Because now person can have its own ability to do things. Now the breathing, I can go ahead and say now print person breathing through nostrils, like that. And for make noise, I can say print person shouting. You see? And because I'm still my own class here, you see here what I'm doing? I can go ahead and say constructor. I can create a constructor which passes all the name and nationality and so forth. And now inside of main, I can go ahead and create a person. I can say var Jenny is equal to new. Now I can use new person. Why? Because new person is a class. So now I can say person, and I have to pass name Jenny, and nationality Jamaican, like that. Okay, if I say Jenny, say print Jenny dot name, it's gonna give me Jenny, right? There's Jenny. Because we also know the toString now can go ahead to string and return something. In fact, because we're smarter and we know this language back and right, can go ahead and use the notation here. I'm going to say return. Actually, I don't have to return. I can just go ahead and say name nationality as such. Okay, which means now I can just print Jenny object, because we look at that, Jenny Jamaican. A lot of cool stuff, folks, a lot of cool stuff. But does it make sense though? Now notice something very interesting here. We have person, which at the top, we have animal, and then we have person. We can create a comedian, which will then implement, which will then inherit from person all of the person stuff, but we can also make sure that we implement is funny as a totally different interface. What I mean by that is the following. I can go ahead and create another class here, say class, say comedian, which extends, right? I can go ahead and extend person and implements, we haven't created this yet, is funny. Of course, it asks us to create a constructor, right? We have to pass the comedian constructor, which passes, we have to pass name and nationality. We've seen this before, but now we have to create this one. I'm going to go ahead and create it real quick here. This is going to be actually an abstract, if I wish to do so. Notice if I don't put an abstract, this is just going to be in the background, just going to be an interface as well. But let's just keep the flow here and make it abstract, which means now I can go ahead and say void make people laugh, because right away I added this abstract method. I have a problem here, which means I have to implement it. Look at this, create one missing override, and there we go. So now I can go ahead and say print comedian making people laugh. Just like that. Let me move this to the top here so maybe we're not too confused. Look at this. So what we did here, we have the abstract class animal, and we created here another abstract class we'll call is funny, which has an abstract method called make people laugh. The reason why I know this is an abstract method because it doesn't have a body. Okay, I could have created other methods with body, that's totally fine. But notice the moment I say class comedian, which extends a person, notice a person implements an animal. That is the reason why I have to pass the name and the nationality. And I have to call super, which super? The person super. Okay, to set things up. But then, because I'm implementing is funny, this is how we look at this. This is very awesome. A comedian is what? Is a person, because it extends a person. But also we said, well, there are other things that a comedian must do. Well, it's funny as an abstract class. As in this case, we are implementing a class that could be related, but also unrelated, which means I could go ahead and create another. If we go back and look at our diagram here, I can go ahead and create a clown, which inherits from person, but also would implement is funny. These are still all related to person and is funny, right? However, I can create a very different class, TV show, which may inherit for something else. In fact, I can go ahead and do this right now. Let's create another class here. I'm going to create a class called TV show. Right? I can go ahead and just string name. Very simple, nothing big. But guess what? I can actually go say implements is funny. Look what's going to happen. We have to. Is funny, right? I made a mistake here. It has to be is funny like that. Look, now we have to do what? Force to override that method. You see? Now I can go ahead and say print TV show is funny and makes people laugh. Is TV show related to comedian at all? Not really. TV show is not a person to start with. TV show could be related to a TV program class that we don't even know where it is, right? But look, it still can go and implement is funny. So any class that we can create can always go and implement is funny, or even for that matter, go implement animal, because those are interfaces or abstract classes, right? Because they allow us to provide common, sometimes not so common, functionality to unrelated classes. That is the key point, to unrelated classes. TV is unrelated to comedian, is unrelated to person. It's even unrelated to animal, yet it can implement is funny. You see? Very good, very good, very good. So here is my challenge to you. I want you, if you can indulge me, I want you to rewatch this video and the past video so you really understand what I'm talking about here. Now, the reason why I want you to understand this, because this, my friends, is one of the most misunderstood concepts in any object-oriented programming language. Why? Because there's a lot of technicalities, or there's a lot of technical jargon that it may be very confusing, and most of the times I think people don't understand how to use it. That's the reason why it's hard for them to think about it. So please rewatch this and the previous video where we start talking about abstract classes and inheritance, so you really understand this. If you really get this, what I'm talking about now, what I've taught you for the past 3 videos or 4, then you are set to understand any object-oriented programming language. Any of them, you will understand what's going on. I kid you not, you will be able to understand it, because this is language agnostic, which means it's not just for Dart, it's not just for Java. All object-oriented programming language has this same concept here. The syntax may change, obviously, but the core computer science concept is the same. Therefore, I really, really encourage you to take the time to really understand this. And if you have any questions, please, 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 please ask me, and I will do my best to explain. I'm very excited, and I hope you're still excited, enjoying learning this. Yes, all right, I'll see you in the next video.